In this reactions of alkenes video, I'm going to look at the reaction with hydrogen, which is called hydrogenation. So just as we explained in the introductory video, the double bond is going to break. Remember, it's the pi bond of the double bond that breaks, and we add each hydrogen across the double bond. The process has some conditions that we need to know about. So the temperature required for this reaction is 150 degrees C, and we also need a nickel catalyst. We'll look at a quick example. So we've got a cyclic alkene, but it's got two carbon-carbon double bonds. So that's obviously going to need 2 moles of hydrogen to fully react, and the product will just be cyclohexane. So if we look at an industrial application of this reaction, you can see on the board there I've got a carboxylic acid, and it's got 2 carbon-carbon double bonds. So this molecule actually represents what we call a fatty acid, and it's the kind of molecule that you would find in vegetable oils. The thing to point out is how the carbon-carbon double bonds are arranged in this fatty acid, and hopefully you can see that they're both in the cis form, where we've got the hydrogen atoms on the same side of the carbon-carbon double bond. And that's the case with naturally occurring molecules such as this. So because this has got more than one carbon-carbon double bond, it would be classed as a polyunsaturated molecule, and they have some health benefits. The only problem with it is this would be a liquid at room temperature and pressure. And so what the food industry does is it likes to harden up the oil, in other words turn it into a solid, and it does that by losing some of the carbon-carbon double bonds. Now in this model here we've only got 2 carbon-carbon double bonds to play with. I'm going to hydrogenate one of them. How would I do that? Well, I'd obviously react it with hydrogen at 150 degrees C in the presence of a nickel catalyst, just like we've seen on the previous example. So let's suppose for this partial hydrogenation of this fatty acid, we're going to lose this carbon-carbon double bond here. So what are we going to make? So there you can see there's one of the possible products. We've still got the carbon-carbon double bond in the cis formation. Now notice I said there one of the possible products. The thing to realise is this process can actually produce the trans form of the fatty acid as well. So you can see there's the trans form of the fatty acid as well, and that gives us, or gives the food industry, a bit of a problem, because these trans fatty acids are linked to heart disease. And it's believed that they raise your LDL levels, so that's low density lipoprotein levels, which has problems in terms of your heart, the health of your heart. Another way you could phrase that is they raise your levels of bad cholesterol. Now remember, cholesterol can be good and bad, so it's not good enough to say these raise cholesterol levels. You need to say raise LDL levels or bad cholesterol levels.